All right, so today we are doing 6.7. We're going to review for the test tomorrow. Done, you'll be gone all day Wednesday. It doesn't impact you taking the test Thursday. Is that your question? Does not impact you at all. You will still take the test Thursday. Hold on. Okay, so we're reviewing tomorrow.
I'm sorry.
Okay, so today we're gonna do 6.7. Go over some practice problems. If you want, you can literally work on homework, work on Alex since we're done with the lesson. Top page 22. Yeah, it's like 4-hour drive. It's crazy. Okay, phones are in the blue holder. You don't need hats today. We're going through the lesson. I think it's more straightforward than most of chapter 6 has been, especially the last 3 sections.
Sorry.
Shouldn't have to compete with your voices, okay? So as soon as we're done, we can go over any practice problems, work on homework, etc. Tomorrow, hit the practice test hard. It'll be great. A period, your test is immediately after lunch on Thursday. So if you have extra time, plan on coming in to lunch Thursday here in this room to start your test early. Question? No.
Oh, yeah. No, why don't we?
Yeah, I know, and that's just a no.
No,
there's a 100% explanation, and I've told you guys this before.
Oh, you have?
Yes.
I tried so hard on those.
I've cut those out because I have to compete with people's voices every day in this class, and I have to constantly tell people not to touch each other, to turn around, to take notes, to stop coloring and pay attention, stop talking. So because you guys waste my time so much on the daily, I'm not going to give you one day of fun to review and give you those bonus points if you don't deserve them, you know? So the deal is, I was like, oh, if you guys had, cleaned up your act second semester, I would have surprised you with one. But it's actually not going to happen. So that's it. I'm not going to inflate your grades and give you little free points if you don't deserve it, you know? I have to see you guys work. I have to see the effort and the chit chat. This is not good. I have to constantly always stop. That's why. Yep. Yeah, and because I don't do it for you guys, I don't do it for my D period either.
Yeah.
So, who's intermediate? Yeah. Behavior-wise, but it's also because you guys have 5 more people than they do. You guys literally are a larger class. Oh yeah, I'm screencasting. Because there are people gone. So today, oh my gosh, today is 6.7, solving radical equations. If this is partly from Algebra 1 again, coolio. So solving radical equations. So we've learned how to deal with radicals, but what if I want to solve for x? How do I get it by itself? Literally, you have to get x by itself. Follow the order of operations. So solving involves raising the power of each side of the equation. When solving in this manner, it is not uncommon for the resulting number to not satisfy the original equation. So what do you have to do? You have to check for extra, aka extraneous solutions. What? Yes. This is not touching you. Yes.
So on Saturday, I was also a teacher, right?
Top dog in the house.
So I said it, and you thought I was crazy.
Yeah, of course.
No, actually, I was doing the homework and I was thinking to myself that, and it worked. It helped.
It does work. It does help.
I was writing on my work.
I private tutor, and this is what works.
He was like, what? Yeah.
Well,
He probably
maybe
hasn't
he's the
heard of it
crazy one.
before.
He doesn't know the words, you know.
I tried to explain it to him.
Okay, let's go ahead and let's solve. Step 1, isolate the radical on one side of the equation. So this first example, I have to get this radical by itself. So let's add 1 to both sides. Square root of y minus 1 is equal to 6. Okay, we isolate the radical. Look, there's only one radical. It's on the left side. We're good. Step 2, raise each side of the equation to a power equal to the index of the radical to eliminate the radical. Okay, if it's a square root, we raise each side to the second power. If it's a cube root, you cube both sides. Right, if it's a fourth root, you raise each power to the fourth power. Raise each side to the fourth power. This is a square root. So we're going to square. We're going to square both sides. Okay. So we square both sides. Guess what happens to a square root and a square? They cancel out. And so we have y minus 1. What is 6 squared? 36. Okay. And step 3, solve the resulting polynomial. Okay, so let's add 1 to both sides. Guess what? Y is 37. Yeah, that's it. That's good. Solid. Are we... Oh, wait. Sure. Okay. Why are we talking? Okay, let's try the next one. Uh-oh, we have 2 radicals. We have 2 radicals here. This is an issue. So I have the big radical, the x minus 12 by itself. I need to square both sides.
Alright, first.
So I'll square both sides. Well, I have this radical by itself, because I have a radical on both sides. This is an issue. If I square both sides, I have x minus 12, but then, on this left side, something tricky.
Equals 4x.
2 minus root x times 2 minus root x. You're close. 4
4x
minus 2 root x.
Yo, what the heck?
Okay, well, all you have to do is FOIL. First, outer, inner, last. You ready? First,
Damn,
2 times
Tom.
2? 4. Oh, outer. What is 2 times negative square root x? Negative 2 root x. What is 2 times negative root x? Negative 2 root x. Negative times a negative is positive. Root x times root x is just root x squared. Oh, square and square root cancel out. So you just get x. Crazy. This is crazy. But we're almost done. This is a hard problem. So this is going to be 4 minus 4 root x plus x.
Wait, hold on. Slow down.
Yeah. So, okay, I have one term with a radical, everything else, no radicals. So now it's just like the first one we did. Get the radical by itself, move everything to the other side. So I'm going to subtract x on both sides. I'm going to subtract 4 on both sides to get rid of these 2 terms. So I have negative 16 is equal to negative 4 times root x. Yep, divide by negative 4. 4 is equal to root x. I have the radical by itself. What do I need to raise each side to the power of? Square. So square and a square root cancel. 16 is equal to x. Cool. Now, this is a problem that I would definitely give my pre-calculus students. Like this is a question I'd give them on a test. Is this a question I would give you on a test? No. It is hard. Because, so I'm showing it to you. I'm trying to gauge to see how well you understand it. Because this is definitely like, you know.
It's more likely to be the first one now.
100%.
Oh, really?
Yes. But I might not give you a square root. I might give you something else. But this is tricky because you have to, oh my gosh, there's so many places. You could easily make a little mistake, right? Knowing you have to square both sides first. What? 2 minus root x squared. We need to actually FOIL that. Foiling, and then having a square root and a square. And then knowing to do this whole thing again to get the radical by yourself. Oh my god, so much. Okay. But it's fine. It's doable. I'm showing it to you because you have all the tools you need. And so I might give you a problem like this on your homework, right? Challenge you a little bit. Try to make you raise yourself to the challenge. But I really am trying to like cut the fat off of my test. I want to see, do you know what I want you to know, right? This is hard. if you do this problem, this would be a great bonus or something, right? But bare minimum, I want you to be able to do the first one. Can you get the first one by yourself? All right, so the next thing is like, oh my gosh, we're not done because now we have to check for extraneous solutions. Is 16 actually an answer? So we have to check if x equals 16 actually works. So I have root of, so I'm just plugging it straight back in. What is 16 minus 12? What's the square root of 16? 4. Square root of 4?
4, 2.
2. Is 2 equal to negative 2?
No.
No. Oh my gosh, so guess what?
So it's not 4.
Yep.
Is
Right.
that the answer? Or do we go
Yes.
back and-
This is the answer. It's because the hard part, additionally, to besides having, having to FOIL with a square root and then doing the whole process twice, you have to take the answer, check if it's extraneous by plugging it back in. Yeah. I'm trying to be very honest with you. If you're trying to so if you're going to take trig and advanced algebra next year, you're going to do this, and it's going to be great because hopefully you will have solidified your foundational algebra, showed you some radical stuff, and you'll be ready because we kind of dabbled in it a little bit. If you're going to petition to be in pre-calculus, 100% you're going to have to know how to do this. But it's a question that I went over with my students a month ago, so it's good. It's good. Okay, let's try another one. I feel like there's some parentheses missing.
Yes, around the end of the-
Okay. When I save it as PDF, I don't know. My computer just doesn't like it. Okay, this is a problem. 100% you have to know how to do. Okay? Ooh, what's the first step we gotta do? We want to get the radical by, okay. So I guess there's 2 right answers. So we could write it as cube root of 3n plus 2, then plus 1. If you need to stand up, let me know. Yeah? Okay. What? Exactly. I wanted you guys to subtract 1. So now I have the cube root of 3n plus 2 is equal to negative 1. Now what? Think about it. What power do I need to raise each side to? Cube it. Right, I need to cube it. Because if I cube a cube root, they cancel out. So I have 3n plus 2. What is negative 1 cubed? Negative 1 times negative 1 times negative 1. Negative 1. Wonderful. And now we just have to finish out and solve for n. What do you get? Perfect. Negative 1. So because we're under an odd root, right, a cube root, the third index, the 3, right, a cube root, we know it's going to work. You can have a negative under a cube root. Now the reason part B had an extraneous solution is because we're under an even, a square root. Remember, you can't have a negative number under a square root. That's why. Let's try D. What? Why did I just explain that? Yeah. Because it's only the square roots, we graph square roots. They look like this. A cube root function looks like that. It's defined for all real numbers. Cube roots, you can put any number under them. Square roots, you only can put positive numbers. So that's where it really comes into play. If you take trig and advanced algebra or pre-calculus, I'll go into that in more depth. Okay, is this where the parentheses are?
Wait, if you only pick square root, then why didn't you pick A?
I mean, I guess I should have. So if we plug in, I have square, because I knew it worked. 37 minus 1 equals 5. 37 minus 1 is 36. Square root of 36 is 6. 6 minus 1 is 5. Because I knew it worked. Yeah. This is where the parentheses are? Yeah? No? Yeah? Okay, cool. Okay, so what's the very first thing I should do?
Yeah, distribute 3.
I'm going to add 2 to both sides. 3 times the cube root of 5y minus 1. Order of operations. What are the order of operations? Can you say them out loud for me? PEMDAS. Please. Right? Parentheses. And then exponents. So you have to do the exponent. you have to do this exponent before you multiply by 3. Is that the 3 you guys were talking about?
So you can't distribute those.
I can't distribute the 3 inside. Because, let me revise. I can't distribute a 3 inside. It would have to be distributing 27 to both of those terms.
Distribute it after you cancel it.
So I'm going to divide by 3 so I can get the radical by itself. Okay, I'm just trying to get the radical by itself.
Oh, okay.
Is that simplest form?
Because I'm just trying to get like radical, nothing being added or multiplied to it. Cube root 5y minus 1 equals 2/3. This is okay, we can deal with fractions, we're good. Now, how do I get rid of the cube root on the left side? Cube both sides. Okay. 5y minus 1. What is 2 cubed? 2 times 2 times 2? 8. 3 cubed. 3 times 3 times 3? 27. Okay. This is not a nice looking problem, but it's fine. We're going to add 1 to both sides. 5y is equal to 8 over 27 plus, if I'm adding 1, how do I make it have a common denominator? How would I write it? Adding 1? 27 over 27. Let's see, 35 over 27. We're almost there. We're almost there. Divide by 5. Dividing by 5 is the same as multiplying by the reciprocal. Yeah. So I could multiply both sides, aka divide by 5 on both sides. And the reason I write it that way is, guess what? It helps me with my answer a little bit. 7 over 27. And that's a cube root? We're good. We're good. Yes. So this one, solid. This is totally fine. The issue is when I have more than one radical. Right? If I had a square root on both sides, because that's significantly harder. Because you have to do the whole process like twice instead of just once. Is that what I told you?
Yeah.
Okay, yeah. That's fine. I guarantee that's not what I told you, but I'll allow you. Yeah, I know, but for the most part, you can assume I'll give it to you. I mean, so I'm gonna do a couple of example problems. Is that okay? There you go. All right, we're gonna do. I'm gonna pick a couple problems from the study guide for us to do on the next page. Huh? All right, work on number 1. That's a good one. What else? Yeah, work on number 1 on the next page. Now, have you heard of something called rationalization?
Yeah.
Yeah. So if I want to rationalize it, 1 over root 3, you multiply by root 3 over root 3. So x could equal root 3 over 3, or 1 over root 3. Notice the x was not under the radical. X is not under the radical. Tricky trick. Ah. So if you're done, okay, if you're done, try number 2 and number 3. Yeah. Yeah, number 2 and 3. Are you done with number 2 and 3? How was the writing? Can you write it all?
No.
Let's see. Did you break it? What did your doctor say?
Like, little baby. Little baby one half.
Yeah. You can't fly it. They're opening it up. TSA?
Oh no, sometimes
I've flown.
Yeah. TSA will make you take off the cast.
usually like
No. Yeah, they were.
I watched a couple people. Yeah.
I've flown with the cast before.
about
It's because you're a baby. You're a little baby.
I was 13.
You're a baby. Yeah.
Oh my god.
No, they've done it to like they've done it to
Mandatory reporter.
He was like 7.
He's wearing it like an actual hat.
I've literally watched someone have to get their cast taken off.
Wait, you cast?
Yeah.
Yeah, dude, that's what I. That's
Okay.
Was it on
Let's
the
keep
cast?
going. Yeah.
Can I try free?
Like a full on like hard cast?
Yes.
They saw they
Yeah.
saw it all.
And that's
What
what
they
they
did
And-
to me is
well-
they took a cotton swab and they like put it in.
So when I had to fly back to Boston after my shoulder surgery, so I literally like was in a sling and I could not move my arm. So they like touched everything and like ran little tests to make sure I didn't have gun residue or whatever. Whatever.
Yeah, we see like.
Yeah.
the-
Okay, number 2. How do we feel about number 2? Are we ready to go on? So, yes. If you check 15 plus 4 plus 1,
I've had a cast every year since like 13.
2 times 45 plus 4 plus 1. So 2 times root 49 minus 1 plus 1. 2 times 7 plus 1. You get 14 plus 1, so 15 equals 15. We're good. To check it. We're all trying number 3. Like, I already asked you guys to do it. I know. Shh. Come on, let's finish out. Did you guys finish number 3? Did we finish?
Dude, you're giving that 2019 pass, bro. Come on.
Squared, squared. X plus 1 is 36. Minus 1, x is 35. So these first ones, of course, are going to work because there's no extraneous solutions here. If you like go to check 35 plus 1, 8 plus, let's see, square root 36. What is square root 36? 6 is 14 equal to 2? No. Doesn't work. What? It's because the principal root. So if you have an even index, taking a square root, a fourth root, a sixth root, like when we say what's the square root of 4, you're always like 2. But secretly, like when you square -2, it's also 4. Let me like write what I'm trying to say. If I say what is the square root of 4, you're like, oh, it's 2. But we know there's 2 different numbers where if you square them, it's equal to 4. The principal root is always the positive one. That's why we're getting these weird answers. Because imagine if I said square root of 36 was -6, this would work out.
What's 65 divided by
65 divided by 2? 32.5?
that's one of the
Where? Oh, you're down there. Got it. I can get you. I'll answer it in just a moment. So you guys have 20 minutes left. I would use this time to work on homework or Alex. You can either work on homework or Alex. Feel like you mostly understand this. You just need to check your work every time. 20 minutes. Homework or Alex.